All right, folks. Welcome. Welcome to the start of the sessions for the week. I love going at the beginning, so everybody's all high energy and you're not all fatigued out from all the announcements. This is BRK3292. It's a session on Azure Blob Storage. So just to kind of get a feel for the room, how many of you already use Blob Storage in your applications? All right, most of you. Excellent. So what we're going to cover today then is going to work well because we're going to spend very little time on introduction. Being a 300-level session, what we want to really spend time on is showing you what's new. Right? So that's really the core of what this talk is going to be about, and showing you how you can apply it for the applications, for the usage that you're already using Blob Storage for. In particular, we're going to spend time diving deep into scale and performance. That's something we've spent a lot of time over the last couple of years really working on, and I think you'll be very pleased to see the improvements we have to show you in this talk. Of course, a talk isn't a talk without us having our customers and partners tell you how they're using the platform in real life. So we have a customer and a partner that are going to come up and talk about their experience with Azure Storage. In terms of related sessions, this kicks off a series of sessions around Blob Storage. Of course, you're in that first one here. We have a couple of talks on Wednesday, one on Thursday, and a couple on Friday. If you're interested in using application of Blob Storage to vertical industries, as well as a deeper dive on OneDrive's usage of Blob Storage, the Wednesday talk from 2:15 to 3:30 will do that. The Wednesday talk, a little bit earlier, actually, from 12:45 to 1:30, is going to be more of a Q&A just on OneDrive. For those of you who don't know, OneDrive and SharePoint Online are a multi-exabyte store built entirely on top of Blob Storage. That's where all of that data, if you're using any of those services, ends up. So we're doing a kind of a joint session with them where we're talking about the application patterns and the challenges that they and us have faced in taking that service to the scale that it runs at today. How many of you are familiar with ADLS Gen 2 or Azure Data Lake Storage Gen 2? Okay, fewer, which is good. This is a very recent thing that we've started a preview of Azure Data Lake Storage Gen 2, which brings together the best of Azure Data Lake Storage and Blob Storage into one service layer. The preview started in the end of June. We aim to GA by the end of the year. So if you're looking at how do I use Blob Storage in my Hadoop workloads very seamlessly, this is a good session to go to. And finally, on Friday, we have two sessions. One is diving deep, like we're diving deep into scale and performance today. That one will dive deep into the security features and the durability features that we've added to the platform. We'll cover that at a high level today just to give you a brief overview, but there's so much new there that we moved it into its own session. And the last talk on there, we'll be talking about the serverless compute architecture and how Blob Storage is pretty fundamental to that. If you're new to Blob Storage and you're like, hey, where do I get started? This learning track from previous conferences, actually a series, if you watch them in sequence, it gives you a pretty good view of how do you get started with blobs, how do you program against them, sort of the basic stuff. I'm not going to cover that here, and since especially many of you are familiar with Blob Storage. So let's start at the top. We're a team that builds the unstructured storage platform for all of Azure. That means we also build disk storage, which is all your persistent disks for your virtual machines, premium disks, standard SSDs, all of that, and the recently announced Ultra SSD. We also build the file storage platform, which is Azure Files, and we're working with NetApp to build the Azure NetApp Files service. But of course, this talk is about blob storage, and that's, object storage is what people think of. And you talk about cloud storage canonically, it is about blob storage. In addition, of course, we have data transport services to get data in and out of the platform. And as you saw earlier today, in the sessions, we have significant new announcements in terms of expanding the DataBox family and what we're able to do there and getting data from small amounts to very large amounts into the platform, as well as having that edge and gateway solution to make using your blob storage solution much more seamless across the edge and the cloud store. And lastly, we have hybrid storage features. We have our Store Simple product that shipped a few years ago. We have Azure File Sync that just GA'd this year, allows you to convert your Windows file server into a cache and keep your master copy of data in Azure Files. And we have Avere, another product. Unfortunately, there's a parallel track talk going on right now, but you can catch the recording. That's about providing burst computation to the cloud, being able to have the Avere virtual appliance reach in and read data from your on-premise EMC, NetApp, etc., and push that data very seamlessly and give you an NFS mount point, either that way or mount against blob storage. So it's a very nifty product as well. It went into preview a few weeks ago and will GA by the end of October. So this is sort of our broader product portfolio. I'm going to dive into blob storage as a topic for today. And blob storage is, our object storage platform, stores and serves unstructured data. We call it sort of the durability layer for Microsoft, because every service that you use from Microsoft, and not just Azure, but from Microsoft broadly, runs directly or indirectly, stores their persistent data inside blob storage. So it allows us to run at a scale, it allows us to eat our own dog food and have this exabyte scale service available for all of you to use. And this is reflected as well in this right-hand side sort of wheel, which is all of the Azure services that have integrations with blob storage, either directly or indirectly. So whether you're looking at something like the app services platform with search, with mobile apps, web apps, they all allow you to use blob storage. The compute services, certainly you can access blob storage from your containers, your functions, etc. Even higher layer services like media and CDN, they really rely on blob storage for storing the media assets, transcoding them, etc. So in a very, very real way, blob storage is at the center of our whole data in Azure app ecosystem. It's also reflected in the fact that blob storage is one of the oldest services in our platform, along with networking and compute. It was the PaaS compute back in the day. It was the first service we previewed in 2008 when we launched the first preview of Azure. So it does enable many scenarios. I'm sure many of you are using it in interesting ways. We'd love to also learn more from you about how you're using it. I want to take a little bit of a peek behind the scenes and talk about architecture and how we built that blob storage platform. And when I say blob storage platform, I'm really talking about the entire Azure storage platform. This is one of the key unique things that we've done, the design decisions we made over a decade ago. All of the different services I just talked about, blobs, files, and disks, are built on a single unified storage architecture. So they have a single layer of hardware that is managed by the software and made efficient. Of course, we have different SKUs of hardware. We have lots of stuff that we do around how we use disks versus SSDs versus NVMe, etc., to give you the performance characteristics and virtualize that hardware to give you scale points. But at the end of the day, all of that data lives in that same single storage layer. The components of this layer are as follows. You have first this stream layer, which is where we store, it's a distributed file system essentially, and it's an append-only file system. It gives us the strong consistency, the encryption at rest, the durability. This is the layer that monitors the machines, the hard drives, the racks, etc. So if there's failures, it's the one that realizes, hey, I've got less replicas than I need here. I need to go replicate data over. If there's any kind of power failures, anything else, this is the layer that deals with bringing everything back up. Above that sits the partition layer, which allows us to actually build the abstractions of blobs, files, disks, etc. The stream layer just thinks of things as byte streams of data. The partition layer gives you that concept, those abstract concepts of blobs, files, and disks, but also does scale out. Right? So it is the layer that realizes, hey, there's a lot of queries coming in on this portion of your storage account. Let me serve those files from many more servers, right? Because the underlying place in the stream layer, your data is really only in and replicas, either it's in replicas or it's erasure coded. The partition layer is the layer that says, I know how to cache this, I know how to have the index of your namespace on it, I know how to do all of that and monitor load balancing. So when we say storage is a dynamically load balanced service, what we're really talking about is this layer and all of this stuff that it's doing to kind of keep things up. Of course, above that, we have the front-end layer, which is more what you'd expect. Any kind of request handling. So all your REST API requests come in here. We do authentication, we do billing, metering, we do throttling if there's something bad happening. We do all of that at this layer. And this is the thing that also kind of knows finally that this is your storage account, this is what you're asking for, and then it hands off to one of the layers below. There's a lot more complexity. Obviously, this is somewhat simplified for the ability to explain. But we do things like caching at different layers. We do persistence at different layers. So at the end of the day, what we're striving to do is give you the best performance possible in this virtualized environment. So one of the ways we like to talk about our platform and the features is through this sort of narrative of what are the challenges, what are the things that we help solve. These are things that you as an app developer that cares about storage are very familiar with. Durability and availability of your data, security and compliance. Those are probably jobs 1 and 2 or jobs 1 and 1 for anybody who cares about storing data as an application developer. Then, of course, you care about scale and performance. You care about manageability of that storage pool. You care about cost efficiency. And then you care about doing this in a way that's extensible, that's open and interoperable, so you don't have to have these data silos and have challenges later as you build other applications of how you access the data. So that's kind of the way we look at this platform, and that's the place we'll use to talk about the different features that are coming up. So to get started with durability and availability, I'd like to ask my colleague Klaus to come up and talk through.
Thanks, Mashi. So I can't really talk about durability and availability, and it doesn't sound like the speakers are working yet. I'll just talk loud. There we go. Durability and availability, I can't really start talking about it without talking about replication options. So we start out with locally redundant storage or replicated storage. It basically keeps multiple copies within the same region across different disks. So we do protect against disk failure, and that gives you the 11 nines of durability that we provide with LRS. The next one is GRS, or geo-replicated, and this basically provides, similar to LRS, multiple copies, but in 2 different regions, typically with 300 plus miles between them, that are async replicated between them. Third is read access GRS, which is like GRS, but it provides read access to that secondary. And programmatically, or from the application, you can see what the state is of that replication RPO. So you can understand how far that secondary is from the primary as far as being consistent. And lastly, zone redundant storage, ZRS, which provides copies in different fault zones within the same region. And those are all synchronous writes between those copies. So that gives you more durability than LRS at a slightly higher cost. And I will add that this slide shows you the cost from lowest left to the highest to the right. We currently are available in 8 regions for ZRS, and that's up from what we announced last year, and we're going to continue to roll ZRS out to every single region. Now, something new that I wanted to touch upon is customer-controlled failover, which we're bringing out in preview very shortly. In the unplanned failover, which is the first scenario that we're going to support, it basically allows the admin to do an unplanned failover of their storage account. So you don't have to wait for us to call a storage failure event or a region event. You can actually do that on the storage account level, which puts more control in your hands. The second scenario, which we'll bring out after that, is a planned failover. So if you're doing a DR test, or for whatever reason you want to fail over from your primary to your secondary, you can do so without any data loss that we would actually have with the unplanned failover. And that will also allow you to swap back. Third is a transparent failover. These first 2, the unplanned as well as the planned, requires human intervention. So the transparent failover is nice for the 2 a.m. scenario, where you'd like the system just to fail over without waking somebody up in the middle of the night to make a decision. Because at least for me, when I make decisions at 2 a.m. in the morning, sometimes I make the wrong one. So double-clicking on that first scenario. In the case where you're using GRS and you have your data in a primary and secondary, the user or admin will select an unplanned failover. At that point in time, it'll show what region it's going to fail over to, which is the GRS pair, so that's known a priori. And it'll also show what the current RPO is, so you know what the state is of the replication between those two regions. If the user confirms at that point in time, it goes ahead and does that by invalidating the playback queue or the log file that's going to be played on that secondary region, and making the secondary the new primary using LRS. And the user does get notification that that's happened. At that point in time, the secondary region is a fully writable copy or writable zone that can be written to. Now, we will continue to bring down that RTO as far as the amount of time it takes, as well as work on those other scenarios that I mentioned on the previous slide. So I'm going to move into security and compliance. The first one is encryption at rest. We GA'd this about 6 months ago, but it wasn't 100%. Does everybody know about our customer managed keys? Oh, okay. It's a good topic. That's great. So we had Microsoft managed keys before this, but we got a lot of customers saying, hey, I want to control the keys. I don't want Microsoft to be in charge of the keys. I want to control them to make sure I know when to rotate them. Microsoft can't supply a key if they're asked to. I want to control them. And so with customer managed keys, that's exactly what it sounds like. You own the security keys that we encrypt your data with. So it puts it fully in your control. The second security and compliance feature is firewalls and virtual networks. This is a security in depth feature, which allows you to constrain access to your storage account to specific VNets, IP addresses or IP ranges, as well as to Azure Monitor, which is those last two items, or trusted Microsoft services. I will add that the trusted Microsoft services does not mean all Microsoft service. It has to be a trusted Microsoft service, which is a subset of our Azure services. The third feature is Azure AD and RBAC. Who here knows about account keys and shared access signatures? About half? Okay. I'm glad Vamshi raised his hand. So with Azure AD and RBAC, it allows you to authenticate to your storage account using your Azure AD credentials. And you can do that either programmatically or from an end user standpoint. And so it gives you a lot more granularity because you can base it on a security principle that has its own policy and control. And so that gives you a lot more granularity, including RBAC, role-based access control, to figure out how you want to control access to your storage account. It's currently in preview, and we're heading to GA for that functionality. And last, immutable blob storage. You might think of this as worm, write once, read many. We like the name immutable blob storage. Not sure why sometimes, but that's what we called it. And it is designed to provide two different policy controls. The first one is a time-based control where you can specify the amount of days from 1 day to 400 years, right, long time, that a blob or a set of blobs cannot be deleted or overwritten. So if that policy is in place and you put blobs in that container, they are sacrosanct for the amount of time that you specified. And that also holds as that data moves across tiers. So hot, cool, or archive, we maintain that property as it moves across those different tiers. That also lowers your cost once you get to that 100, 200-year mark. Might be slightly different by then, but we'll see. The second policy type is legal holds. So we support legal holds via tags. So if a tag is present, we do the same thing as the date-based policy. We prevent deletion or overwrites of those blobs. We're currently we actually just GA'd it, I think it was 6 days ago. So immutable blobs is now ready for everybody's use. I will add one thing to this. If you set this up for testing, be careful, because if you set this up with a long retention period, it will lock that data. So luckily, once you delete or once all of the blobs time out, you can go back and clean those containers. I have one container I'm still waiting for. I have 2 more months before it times out. And then I'll be able to clean that up from one of my test subscriptions. With that, I'd like to turn it over to the other. I'm Klaus. This is Klaus. A little confusing. Just call us whatever you want. But
am I on? All right. Let's talk about blob performance. And, all right, so we have our cloud storage today, as we just talked about, right? Cloud storage, massive scalable. You can get just-in-time provisioning of capacity, performance, etc. And it's a natural fit for the web scale applications that is being used for today. Now, we do have customers who are asking us to provide additional throughput, especially to a fewer number of objects. So they want massively throughput to like a single object, etc., to drive high-performance compute, big data analytics for things like genomics, autonomous driving, and scenarios like that. So we're going to talk about that in more detail in a second. The second aspect is they want faster data access, right? So especially in use cases where you have a human in the loop somewhere, where humans are not very good at waiting on stuff. We wanted immediate gratification, right? So if I am sitting and I'm doing some editing of a video, et cetera, it needs to happen immediately. If I'm waiting on a transaction to happen, it needs to happen immediately. So faster access time to object storage. And then finally, cost efficiency. There is a class of workloads that sit on top of Azure today that has a high number of transactions on a relatively small data set. And when you get into that situation, the transaction cost becomes a dominant factor in the bill you get. So they're asking for a more efficient way to do that. So let's take a look at these new requirements. So the first thing I'm going to show is high throughput blob is what we call this. So let us first orient ourselves a little bit about what you're looking at. So you're looking at 3 windows. Hopefully they're all familiar to you. In the upper left corner, you're using Azure Storage Explorer. We're going to look at our storage account there. To the right, there is good old Perfmon that has been in Windows for decades, where we're going to see the worker VMs and what they're doing. And in the lower left corner, we got our application orchestrator that is orchestrating workload on a few worker VMs. So let's start by zooming in on our storage account. We look at our blob containers, and there's nothing there. Okay. So let's go and look at our test application here. So what this application does, using 4 worker VMs, it puts 50,000 blocks into object storage, each 32 megabytes in size. So who has already done the math that we're actually writing 1.5 terabyte into Azure? See, I did it, but I knew it up front. Now, what you see in the Perfmon window here is you can see the high throughput, instantaneous throughput that each of these VMs are getting in terms of total bytes per second sent over the network. I accelerated a little bit so we didn't have to wait for it. Now they're all completed. And the test application reported out that it took 119.7 seconds. So just short of 2 minutes, it took me to write, or actually it took Azure to write 1.5 terabytes of block storage. That means we just wrote at 106 gigabits per second into Azure storage. That's 12.5 gigabytes a second in a single blob. So let's go check our storage account again. And let's go refresh. All right. And we have a container named container. And in that container, we have a blob named blob. Like very cool names, right? And it's 1.5 terabytes in size. How about that? Now, so what you saw was the high throughput blob feature is specifically focused for this demo about write, right? So you saw an ingest of a large blob with very high throughput. It was instantaneous. There's no need for our layers to sit and warm up and do partition splits and all that stuff that you might have seen in the past. It was just performance right there and then, right in that second. And then the last piece, which we did not show, was that the container and blob naming does not matter. So even if you have a large number of objects and they have a long name that only ends with -1, -2, -3, that is no longer an issue when you write through high throughput blob. You can choose whatever names you like, and we will happily write it for you. Now, already out there is some of the read enhancements we have done, including the inverse of the write performance, which is egressing the data from the account at a similar speed. If you come on a Wednesday talk, I will demonstrate that live as well. And then the acceleration of frequently read blobs. So if you have a set of reference data where you often come back to, then we will promote that data higher and higher in the caching layers to get lower and lower response time as well as throughput for that data. I want to show you something else. This is a preview of blob storage, premium blobs. So what you're looking at here is two windows. It's on the same VM in Azure. The one on the left is an application running against our standard object storage that has been around for a long time. And then the one on the right is running against the storage account in our new premium blob storage that we just go to limited public preview today. Actually, the blog post just went out at 4 p.m. So what is happening is that from this VM, we're looking into a data set. Each data set is 1 million blobs, each 64 kilobytes in size. And from that, I'm going to read 1,000 random objects. I'm going to do them one by one. The reason I'm doing them one by one is to highlight the effect of the shorter latency that you will see in premium storage. So by reading one by one, I'm stacking them against each other. So let's go ahead and fire that up. We're going to give the standard account, and then we're going to fire up the premium account. And I think at this point, I probably did not have to label which one is premium. So we saw 64 kilobytes objects on average read out at 5 milliseconds. But let's go ahead and speed this up. Let's let time help standard a little bit. And we see that that takes about 10 times as long to do the same operation as here. Now, in many applications, this will be very useful, especially when, as I said, where you have some person sitting and waiting on data to be retrieved out of object storage. So premium blob storage preview, it is essentially the same Azure object storage that you know today, where we back it by solid-state drives. Solid-state drives are known for high transaction rates and very low latency. And even more important, or not, I shouldn't say that, it's not even more important, but equally important is it is very consistent in providing that latency to your application. Now, we will support both block blobs and append blobs on this type of storage, and it will be the same set of APIs that you would use against standard hot, cool, and archive. It is available in local redundant storage, and at some point after we release it, we will also be able to tier down data that you store in premium into hot or cool and so forth. So that once data comes in, it's really hot, and then over time it cools down. You can then tier it into the cheaper capacity storage. Now, so what does that mean? At the end of the day, it means that if you look at Azure Blobs today, we have double-digit millisecond latency, we got a certain capacity, we got 500 transactions per object, and 60 megabytes of write performance. I probably already gave away the last row here when we pull away the curtain and look at where we're heading. So the limited public preview, we can do 20,000 transactions on a single object, and we could do 12.5 gigabytes a second in and out of a single object. That's significantly higher than 60 megabytes a second. And then with premium blobs, we can then get down to single-digit millisecond latency, which opens up for a whole new class of application that can find their way into Azure. All right? And both of these features are available in limited preview. The first one, you can write that alias, and you will actually write me and a few of my friends. And the second one, there's a blog post coming out. It is actually out, or if you go there, you'll find how to sign up at the bottom of that blog post. So with that, I'm going to hand it off to Torsten.
Thank you. Good afternoon, everybody. My name is Torsten Grabs. I'm a product manager at Snowflake, and I've been heading the Snowflake on Azure project for the last several months, and today I want to talk a little bit about how we have been porting Snowflake to Azure, and in particular how we have been using Azure Blob Storage. Let me start off by a brief introduction into Snowflake. If you have not yet heard of us, Snowflake is the data warehouse built and designed from the ground for cloud computing. And it helps organizations, enterprises to run their analytics at scale in the public cloud, and helps them to become data-driven organizations. There are 4 areas that I picked that I think make Snowflake really unique, and I tried to capture them on this slide. The first one is concurrency. So we allow an unlimited number of users to run essentially a virtually infinite amount of queries all at the same time in Snowflake to process their analytics. We do that with a very clean separation of compute and storage, in our case now, Azure Compute and Azure Storage, so you can scale storage and compute independently of each other. Snowflake also provides you the built-in resiliency so that you don't have to worry about transient failures in the cloud. And it gives you the security primitives that you need to feel confident to move your data into the public cloud. So how do we do all this? From a very top level, we are following a SaaS architecture approach. The key concept, the first one that I want to introduce on this slide, two more concepts to come, is the Snowflake database. And you essentially load either structured or unstructured data into a Snowflake database. As you load the data into Snowflake, we are transforming that data into an internal representation that's highly optimized for analytic workloads. And this then gets represented as files in Azure Blob Storage. Now, in order to run analytics over that data that's stored in Azure Blob Storage, we are using Azure Compute, and we are wrapping a set of VMs in Azure Compute into what we call a virtual warehouse. So a virtual warehouse is essentially a set of machines in Azure Compute that runs your analytics. What's great about it is that you can create as many of these virtual warehouses as you may need for your organization. So you may have different teams, different departments, different workloads. You can create individual warehouses for each of them, and that makes sure that you're not ending up with any contention around resources between different teams and different organizations. Probably the most demanding workload is typically BI reporting and dashboarding. Here, I want to introduce you to the third concept, which we call multi-cluster warehouses. So with a multi-cluster warehouse, you can add additional compute capacity, additional sets of VMs to your logical warehouse, and then incoming requests, queries are then distributed across the different clusters in the same logical endpoint. All of this is wrapped by a set of management services around it that help you manage your Snowflake accounts from a security perspective. It captures metadata and it does the optimization for the requests that are coming into the system. So with that, let me tell you a little bit more how we have built Snowflake on Azure. Our first and primary goal was to give you the same familiar Snowflake experience and to give you the same surface area wherever possible with the same set of features and capabilities. There are a few places in the surface area where we had to make extensions to embrace Azure as a surrounding cloud provider. Probably the most prominent scenario here is, again, Azure Blob Storage. For data loading and unloading scenarios, we had to make extensions to our surface area to support Azure Blob Storage. Snowflake on Azure is currently available in the East US 2 region, and as we are speaking today, we're working on other regions that will be rolled out later this year. I'm looking at the right-hand side of this slide now. It shows you the stack that we are using to implement Snowflake on Azure. At the bottom, you have Azure Blob Storage. This is where we are storing the files in our proprietary format. We're using Azure Compute VMs on top of that to power your virtual warehouses. This is a place where your analytics run. And then the rest of the stack uses a mix of Azure Compute VMs, Azure Blob Storage, managed disks to implement the management service layers. So let's drill into this in a little bit more detail. So here at the bottom, you're seeing one-to-many Snowflake databases that are essentially the containers that hold your data files that Snowflake manages for you in Azure Blob Storage. We are relying on Azure Blob Storage to give us virtually limitless storage capacity. So you can put as much data as you want into Azure Blob Storage. Now jumping up to the top of the stack, here we're using Azure Compute, and it's for similar reasons. Azure Compute gives us that virtually limitless compute capacity that our customers need to run their warehouses. And here you see one such warehouse which uses a couple of VMs. As a query gets submitted into the warehouse, each compute node in the warehouse pulls a set of files from Azure Blob Storage and then does the processing on top of it. So some of the things that we're using here is we are using a tiered storage management approach where we're leveraging the locally attached disks on the VMs to hold on to files from Blob Storage that are frequently used by analytics on that warehouse. Remember that customers can create as many warehouses as they need, and they all have access to the same shared set of data. That puts us in a place where we need to make sure that we're getting highly scalable access to the shared data that sits in Azure Blob Storage. And our warehouses can, in a single cluster, go to more than 1,000 cores. And remember that multi-cluster concept that I introduced you just a couple of slides before. If you take that to the limit, you end up with a compute capacity that's more than 10,000 cores that all will operate and pull data from Azure Blob Storage. So let me show you some of these concepts in action. Jump over to my demo machine. Right, so here we are in the Snowflake web frontend, and if you squint, you may see the Azure in the domain name up here. So we're right now connected to Snowflake on Azure Live. We are in the database area of the Snowflake web UI, and it shows you a set of databases that have been defined and created by other users that are sharing the same demo account with me. So one of the databases here that we're going to use going forward is this test database. You can see it's empty right now, no tables defined. You can see a few predefined views and schemas, but no data has been loaded yet. Let's jump over to the second concept that I introduced you, which is the warehouses. This is where your compute capacity sits for Snowflake. And you can see we have a number of warehouses predefined. And this one here is the warehouse that I've defined and set up for the demo, and I see it is not started right now, so it should let me go in and resume this warehouse again. And there we go, it started. If we look at the configuration button for it, you can see I can control the size of the warehouse. That's essentially the number of nodes that we're using in the warehouse. And the more nodes you provide, typically, the faster your queries are being processed. The next dimension is the number of clusters that you allow for it. And that's essentially the degree of concurrency that you can support through that logical endpoint. And you can see you can go up to fairly large sizes here as well. And you can define a number of other properties that I'll jump over at this point. Let's look into the worksheet experience here and go through some SQL statements to exercise that the cluster that we just created. So let's jump over into the test database, run a create schema statement to create a demo schema, and then also hop into that demo schema. The next statement that I'm executing right now is a create stage statement. What this does, it essentially provides a pointer at this point into Azure Blob Storage. And this is the Blob Storage account that I'm pointing to. And it's a regular Blob Storage account. It holds a predefined data set. For those familiar with databases may know the TPCH benchmark. And if you look at the folders that you see here, those are the typical 8 tables that you load with a TPCH benchmark. And I've preloaded the files here in the Blob Storage account for TPCH scale factor 1000. That should be a terabyte worth of data, and we are just going to work with the customer table here. Let's create this table, typical shape for TPCH, and then let's run a copy statement. So the copy statement is a statement that takes the data out of your staging area in your file format. This is gzip compressed CSV that I'm using here. And we're loading that into the table that I just created. And as part of the load operation, Snowflake is optimizing the data and putting it into its proprietary file format. Now we have loaded the data. It took us about 15 seconds. We have 150 million customers in here. Let's look at a few of them. And you can see it's artificially generated data, so that's expected. Okay, now we have one table populated, but that's boring, so let's create a second table. And let's use a different kind of storage here. So again, let's create a stage, but in this case, let's use a different storage account. And this storage account is interesting because it uses Data Lake Storage Gen 2, the preview that we just heard about. It has a set of files that are essentially representing tweets that have been submitted by the customers that we've just loaded into the customer table. So let's create a file format to deal with the JSON representation of those files and take a quick look at how the data looks like. And as part of this statement, you can see some of the semi-structured data functionality that Snowflake supports. So you can see how I'm pulling out properties from the data for the customer key and the actual tweet. So you can see the customer key down here. You can see the actual tweet. Let's pretend that we are happy with the shape of the data. Let's create a table to hold it and then copy the data over from ADLS Gen 2, again, into Snowflake's own representation. And that should take about 15 to 20 seconds. And then we can run some more interesting queries. We'll show first how many tweets we got. Should be in the order of 3.2 million. Just to make sure that I'm not cheating, let's look at a few of them, and you can see the familiar structure here. So that you get a sense of the sizes, let's jump back over into the data view in Snowflake, and you can see here, those are the two tables that we created. 3.2 million rows for the tweets, and 150 million for the customer table, and they're all in the order of a few gigabytes worth of data. So let's run a more interesting query over this. And this is a statement, a select statement that joins the tweets table with the customer table and looks for one specific customer that we filter on by phone number. And then we want to see all the tweets for this particular customer. So this just gives us one result row. But let me pull up the query plan for this query to illustrate some of the things that we talked about. So if you look at the table scan operation for the customer tweets, we can see some of the properties and characteristics that I mentioned. So you can see that almost 95% of the data to answer this query for that particular table have been pulled from our on-disk cache on the machine. So you can see our tiered storage management at work here. You can also see that we didn't have to go through all of the files that back this particular table because many of them did not qualify for the query that I submitted. So we pruned those from the query to give you better performance. So those are some of the principles and optimizations at work. And if you are more interested in a BI workload, you can obviously use tools like Power BI Desktop here and put them on top of Snowflake as well. And let me refresh this query here. They can see it actually working. It should take a couple of seconds to just refresh the simple pie chart here. And Power BI Desktop makes it really easy to get the data from Snowflake. If you go into the database section here, you can find Snowflake down here as one of the databases that you can create data sources for. So with that, let me jump back into some slides to just talk a little bit about what are the architectural challenges that we face when building Snowflake on Azure. The first one, and that hopefully has become clear by now, is storage bandwidth. As we fire up huge compute capacity, we need to make sure that we can pull massive amounts of data at speed from Azure Blob Storage into our compute layer. We also, at the same time, want our storage to be cost-effective. So an intuitive approach might have been to just use premium storage, but a lot of our customers are actually using Snowflake as a data lake as well. And as is typical with data lakes, you have a lot of data, historical data, that is very rarely accessed and is not as performance critical. So premium storage would not have been a cost-effective solution for those customers. And then the third challenge is we need highly elastic compute. Our customers are sometimes firing up more than several thousands of cores within the order of minutes, and they expect this elasticity to be more or less instant, so that capacity needs to become online and up and running very, very quickly. We've been working very closely with the Azure teams as we were building out Snowflake on Azure, and here are some of the features that we have used to make this possible. The first one is the high-scale storage accounts, which gives us that additional boost in terms of data transfer and bandwidth between compute and storage, particularly for large warehouses and the multi-cluster warehouses. We are relying on the high-throughput blobs for the adaptive performance improvements, which helps us with frequently accessed data sets to get even better performance for those. A feature that we've embraced during preview was soft delete, which protects us against accidental deletes on the customer side, but also against operator error on our end. And then last but not least, we are using accelerated networking, and that helps us with low latency communication within a cluster or within a warehouse for cross-node communication. Let me share some numbers with you. So we have been in preview for several months now. We have about 200 customer accounts in the preview as of today. And over the last 30 days, they have run more than 17 million jobs. And a job is essentially one of the queries like the ones that you saw, metadata, access operations, data load operations, so everything that you essentially do, every request that you submit to Snowflake. In order to process these 17 million jobs, we have burned through more than 250,000 VM hours, and we've read through more than 9 petabyte of blob data in Azure Blob Storage. And about 1.5 of that, 1.5 petabyte of that data was then communicated via network between the nodes in Snowflake warehouses. We've been very focused on adopting best practices. So I've talked about the tiered storage model. We are also using fairly large file sizes, larger than typical database page sizes, to amortize the cost of round trips into remote storage. We are randomizing naming wherever possible, file names, container names, storage account names. We have the option to shard across storage accounts for additional performance boost. And we spend a significant amount of time finding the best fit in terms of VM SKU for data warehousing workloads and scenarios. We have been fortunate with the customers that have been working with us through our preview. I want to call out one customer specifically, though, which is Nielsen, who has joined us very, very early in the preview. There is a joint session from Nielsen and Snowflake on Wednesday morning, 10:45. And it's co-delivered by Srini Varadarajan, CTO of Nielsen Buy, and Bob Maglia, Snowflake CEO. If you're interested to learn more about Nielsen and how they are using Snowflake, I'd encourage you to attend that session on Wednesday morning. So wrapping up, I'd like to encourage you to try out Snowflake. We are available in Azure East US 2. Go to trial.snowflake.net and create yourself a Snowflake account on Azure and let us know what you think. Thank you very much.
Thank you, Torsten. Excellent. We figured that's a great way to actually show you real usage of all of the features that Klaus just talked about in terms of performance and scale. There's sort of data warehousing and the analytics queries are some of the most demanding things. And being able to build that on top of an object storage platform into the extensions that we've built is pretty cool. So I want to kind of take some time to cover the other two aspects here, the manageability and cost efficiency and open interoperability and the features that we're launching there. Torsten referred to soft delete. This is a feature that went GA very recently. It covers a very common, surprisingly common ask from our customers. I accidentally deleted my data. Can you help me get it back? And so far the answer has been, oops, sorry, we really can't. But now you can. This is a thing that you can just go in and enable on your storage account. Enable, you set a retention period between 1 and 365 days. And then any kind of blob deletion or overwrite will create a snapshot for you automatically. You can go in and then either through the portal or through code or PowerShell or whatever, query your deleted blobs and restore them yourself. You don't have to come talk to us. You don't have to submit a support ticket. It's just self-service at that point. So it covers you in case you have any kind of accidental deletion on your account. You have to make no changes to your blob storage code. So if many of you said you're using blob storage, you can turn this on. It's 100% backwards compatible, doesn't change your code. It just starts now logging and saving those blob deletes and blob overwrites. We will build this then into sort of the next feature that's coming soon is object versioning. So this doesn't give you version IDs on those versions that we save. We'll also now decorate. In order to use those version IDs, of course, you have to change your code, which is why we're sequencing it this way. This can be turned on for all of our customers if they choose to. It is an opt-in feature, and versioning is something you have to adopt in your code. So this is live now. and something you can go check out, and we recommend that if that's something you're worried about, you enable it. Another very common feature when we talk about manageability that is really important is monitoring your own storage accounts. Again, this is one that you really want to do self-service as a developer. You never want to have to call people and do support tickets, anything like that. Now, we've had metrics and logs for a very long time in storage, since 2011. But what's different is we are now fully integrated with Azure Monitor for your metrics. So this powers all the graphs you see on the portal, but it also does a bunch of cool things because you can go write your own custom code. You can have Azure Monitor, deliver it to something else like Splunk, for example. You can stream that analytics data to Event Hub and take action on it. You can archive that data into a different storage account if you need to for compliance purposes or what have you. And you can use the Azure Monitor SDK in a common way across all your Azure services. So you're not saying, hey, I have to go enable this, I have to write some code here, I have to write some code there. That's one of the big benefits is everything inside, every service inside Azure runs against the Azure Monitor SDK. The metrics piece of this is GA now. And what we're working on coming by the end of the year is log integration. So logs, if you've used Azure Storage Analytics logs, those will also then end up inside Azure Monitor, and that with the recently announced Azure Data Explorer, that will actually allow you to run great, very fast queries against these logs. So that's the monitoring feature. Blob tiers. Klaus talked to you about premium blob storage. We now have, we used to have hot and cool for many years. We now have bracketed the, on both sides. We have the archive tier that went GA last December. That provides the cheapest per gigabyte storage in the cloud, right? Per GB, it's an offline tier. On the left-hand side, a little bit about what Klaus alluded to. This is our expected GA pricing for premium storage. While the GB or per TB cost is high, what is very surprising, and it's very intentional on our part, is it actually ends up being cheaper for your high transaction workloads. If you have more than 50 TPS per terabyte, you will end up cheaper on premium tier than you will on hot. That's because we've baked in a 65% lower transaction price into the premium tier. It is cheaper for us to do these transactions on SSDs, as you would expect. Therefore, we pass that cost savings off to you. So this is something, even if you don't care about the low consistent latency necessarily, it's something it's worth looking at your own workload and saying, do I have a high TPS workload, which is worth moving into the premium tier? As you know, the tiers, one of the cool things for us is that we have a unified API, and we give you control as a developer in terms of doing your own blob level tiering. It's just an API call to set blob tier, and you can move that data at a blob level up and down the stack. We'd have had requests, though, and this is a feature that's now in preview, around doing this automatically. I don't want to manage this. I just want to set some rules and have Azure do it. So that's data lifecycle management for automatic policy-based movement. Let's double-click into that real quick. So it is about policies. You can see an example of the JSON policy on the right-hand side. We'll have a nice UI-based way of doing this, but right now it's a JSON object that you drop in there. It allows you to set policies on the account level, on a container level, or on a blob subset level. So you can provide a prefix and say, only apply this rule to all blobs that start with something. And we run those rules once a day. We go through your storage account, we find the blobs that match those rules, and when we do what you ask us to do, for example, things like age blobs greater than 30 days from hot into cool, age blobs greater than 6 months from cool into archive, and delete blobs greater than, let's say, 5 years from the archive storage. So that is no longer stuff that you have to write maintenance jobs around or scripts around. You can just set this up and have it run and execute on our side. This is currently supported in GPB2 and blob storage accounts. There's preview available in 3 regions, and will GA in the first half of next year. This is something that's relatively inexpensive for us to manage for you. It's $1 per million objects managed per month. So the idea there, again, is we don't want to make this punitive for you to use this, because it does help clean up a lot of those maintenance tasks that as a developer or a storage IT admin you end up having to do on your object storage accounts. We're also announcing 8 new archive regions today. When we went GA in December, in fact, when we talked 1 year ago and started a preview of archive, we said we're going to continue growing aggressively into other regions. So all of the regions with the green dots there in the UK, in Asia, and in Australia are all new. So in terms of again, having somebody who uses our platform come and talk to you about us, I would like to invite Josiah Bradley, who's from the Florida International University, as a senior systems administrator there, come up and talk about how they're using Archive for their DR plan. And I'm super excited about this because I've been waiting to show a video like this for all the years that I've been presenting at Ignite or Build. So let me roll the video while he comes up here.
So the video you just saw is from Global FinPrint, which is part of the Paul G. Allen Foundation of agency sponsors. And FIU is a partner, one of the primary partners in helping with this global research project. So FIU is Florida National University. We were founded in 1965. We're a large research university in South Florida. And I'm from the Central IT department. We work with over 300 employees, and we support hundreds of employees in different departmental regions. So why did we choose Azure for our DR site? So how many of you were here for Ignite last year? So a couple of you. So you may have realized a little bit before Ignite last year, Hurricane Irma decided to visit Florida and go right through the entirety of the state. So this was a massive hurricane. It was scheduled to be a Category 5 when it made landfall, and it basically was bearing down on our university. So it went through our university and happened to go through our DR site in Tallahassee. So not only did it was affecting us, it was affecting where our data was stored elsewhere. So we needed to come up with a DR plan that had better geographic separation from our current DR site that wasn't regional, something away from hurricanes and other threats. So we have a massive data set right now that we are backing up from on-premise. It's over 1 million files, and it's planning to grow to 2 petabytes. And people need to get this data fast and recover it quicker than they can today. The data is being collected across the planet from Australia, Americas, and reefs everywhere around the globe. And we need to do this in a cost-effective manner since we're a university. So the solution was to use Azure's blob storage. What we started with was a storage spaces direct file shares for our clients. It uses SMB that they're familiar with, are accustomed to, and can store their data on a day-to-day basis. Mic, turn off. On a day-to-day basis without having to worry about changing what they do. So we used AZ Copy, which is a tool provided directly from Microsoft to get the data from our storage spaces cluster into the cloud on a nightly cadence, and it just transfers the differential so we're not worrying about terabytes of data every single day. What we then do is we use PowerShell and the available REST API, as Vamsh was mentioning. It's very simple. You just tag the blob down from hot to archive, and it makes a true backup of the data so that it cannot be changed from people on premise. They don't see this. It's very transparent to the user. Each user has their own storage account, so we isolate the data, And that way, if we try to retrieve something or back up something for one client, it doesn't affect the other clients, it doesn't intermingle the data. And since we're pairing with Internet 2, we get a really fast amount of bandwidth to Azure. And so we get 5 gigabits plus per second right now, which I know you guys saw a lot fast earlier, but this is still pretty good for our use case. So the benefits this helped for us was that we now have our data elsewhere, anywhere on the planet actually, in any of those available archive regions that we can easily move back and forth, and we're not worried about a hurricane taking out both of our data sites. We also, like I mentioned before, have an easy way to isolate our customers, and adding a new customer is easy as a configuration change and a scheduled script. It's much faster than tape to get our data back now. We used to have to wait for people to go to a tape archive, find the missing tape, and attach it, and they may not even know it was there until 2 a.m. in the morning. So this is definitely a quicker way to get our data back, even though it's maybe in Virginia or Australia. And also it means we don't have to duplicate our efforts to build the same exact storage environment across the country in 2 different sites when we have hurricanes bearing down on us. And it allows for global collaboration of our data. So what happened was we had some of the guys in Australia working on the Reef project need 0.5 terabyte of this data pretty quickly, but they don't have the best internet connection. So what we did was we moved it over to an Australian region in Azure and let them download it at their pace with their internet connection, and it really helped them to get the data they needed in a quick amount of time without having to worry about shipping it over with a hard drive. Thank you.
Thank you, Josiah. And yeah, as I was saying, I've been waiting for years to get sharks into an Ignite session of mine. And I finally found a story where I could get this. But in all seriousness, it's actually super cool for us to see when we talk to our customers, and I hope we talk to all of you during this conference this week about how you use our platform. We see all these amazing uses where people, developers, IT admins, etc., all come together and use our platform in ways we never thought we would see it, and use it in innovative ways, use it for their use cases and help solve their problems. So this is super cool. So last but not least, I want to kind of dive into open interoperability, where again, we have a lot of new things coming. So of course, as you know, a core part of openness and interoperability is having a wide variety of supported programming languages and environments and things like that. We have a broad set of platform support where you can of course code to the REST API, but we give you these convenience libraries. We're in the process of rewriting some of these convenience libraries, moving to an open API and Swagger-based client library, so it's actually easier if you're starting out and not have a slightly different API in every different programming language. This way things become a lot more common. It's actually much faster for us to keep up with the REST API changes, and then we can still add good convenience features on top. So some of those libraries, like the Java library and the Go library, are in preview today. All of our libraries, by the way, both the newer ones and the current in production ones, are all on GitHub. They're all open source. You can go look there, fork them if you need to. We also have the data movement library, and we have the tools like Easy Copy that you just looked at, Storage Explorer you looked at in the demo. There's a newer version of Easy Copy as well in preview. It is dramatically faster than the old one. We built the new one around a job engine and much better parallelization and other things. If you're interested and you're using Easy Copy today, I definitely encourage you giving that a try. It will really be way faster. And it uses all of the new features like high throughput block blobs and other things. If you're a Linux user and you want to just mount your blob storage account at a mount point and use it, we now have a Linux Fuse adapter that's written by our team and shipped by our team. So you can just go mount your blob storage account as a mount point, and then the application or whatever using that mount point really doesn't know. It's a little bit slower, of course, but it really doesn't know that it's talking to a REST API-based object storage system behind the scenes. If you have applications that use S3, we have a number of different partners, the logos across the bottom there, that provide the support and allow you to access and continue to use your S3 API-based applications with our platform. Another thing that's become very prevalent recently, and we had made some announcements around this at Build, is around serverless computing. Serverless computing is sort of functions and runtimes and all are very popular. But what's interesting is what underlies this is always some kind of trigger going to some kind of router, then going to a serverless runtime. More often than not, that trigger is data. Right? It's data arriving, it's an event arriving. That's what kicks off the whole serverless process. So what we've done is at the end of last year, launched blob storage events, which is essentially change notifications for your blobs. On blob creation, blob deletion, you get an event. It's highly scalable, guaranteed delivery. It then delivers to this service, this event router service called Event Grid, which can then do a one-to-many pub-sub delivery of those events to any number of services, including queues if you want to use that, queue it up and process it in batch, into functions if you want to go straight into that serverless runtime, into logic apps if you want to do sort of a more visual thing. So this piece is really well wired up now, and something, again, if you've not heard of it before, I encourage you, if you have these sorts of things, to go try it. So what I want to have do is have my colleague Zin come up and give you a quick demo of this pattern of serverless compute with blob storage.
All right, thank you, Vamshi. I'm just going to pull up my demo. All right, so let's jump right into it. So as you can see, this is a static website hosted on Blob Storage directly. You can see our Blob endpoint. So this is a website, you're going through the web endpoint. And right now, I'm not authorized to view the contents of this page. So let's log in. So this is just JavaScript code running on the client, and it's calling Azure Active Directory to request an OAuth token. So first, it finds out who I am. I'm logging in with my account. I get the permissions, and it uses that OAuth token to go into my blob container and list exactly what is in my container and show this website correctly. So this website right now is just showing an album gallery with 3 photos. So that's interesting, but let's upload a new file. Click file. Let's choose this picture here. Refresh. So now you can see that it has a caption on it. So how did that happen? Well, let's switch back and talk a little bit about the workflow. So as Vamshi was saying before, that was a data trigger. So I uploaded a new blob, which happened to be an image file, and that generated a event grid notification to wake up my function. So Azure Functions is a serverless compute that just runs code when you need it, and it's built exactly for how long it runs. So my Azure function is calling cognitive services, specifically the computer vision description API. So the computer vision description API reads the blob that was just uploaded and returns back metadata. So that metadata is then stored directly on the blob itself, and when you're listing the blobs, you can get the metadata back with the blob. I'm going to show you exactly how easy it is to set all this up. There's really little code involved in doing this. So as you can see here, I had created my static website. You can go access this URL. You just enable it in the portal with one click of a button. You set your index document and your error path document. So after you have your website, you can go to events, which is also on Azure portal. So on events here, you can see I have a event grid created. And what happens is every time a blob is created, it triggers an event. It fires off an event which gets functions to wake up. And let's show off functions. So function says, hey, there's an event coming in. I should go run this code. So this code, all it does is gets the blob, calls the cognitive services computer vision API, and returns metadata. And once that metadata is returned, it writes that metadata back on the blob, and then your static website, when it's listing the blobs in your container, you can see exactly what the cognitive services returned. So you see here, I'm using OAuth again to get a credential token. So this is a service identity. It knows that functions is a authorized Microsoft service to go read my storage account. So once it reads my storage account, it gets the blob that triggered the function to run. And then I tell it to go fetch the attributes and set the metadata. So it fetches the attributes from cognitive services and sets the metadata back on Azure Blob. And then that is displayed on the website. So how much did all this cost? Well, this demo was pretty cheap. So let's say I uploaded 1,000 5-megabyte photos. That'll cost me about 10 cents a month. And those transactions to show it on the website and upload it, it's about 1 cent. And then the serverless calls, there are a set number of calls you get for free, but I listed out the prices here. 1,000 calls is $1, and the function's execution is less than a cent. So overall, it's about $1.15. So this is just a simple example of what you can do with blob events and functions. And there's a lot of templates out there with functions and logic apps where you can set this up pretty quickly. But there's more interesting things you can do. You can call custom vision to run your own models and have computer vision be more descriptive. So if you want to see more of that, you can join our session on Friday and see what else there is to see with functions and serverless compute. Right.
Great, definitely. So if you're interested, please go to that session. We're going to go into a little bit more detail. We'll code live on stage and kind of walk through how to get this set up exactly. A couple of other announcements I want to walk through on this open interoperability area. One of the things we're trying to do is make sure the blob storage API is available everywhere. In the announcements today already, you heard about Databox Gateway and Databox Edge having the blob API, the Databox device itself having the blob API. So in addition, the IoT edge devices will now have the blob API. So they use local storage. These are small IoT devices. But you can just use the standard blob API and access your local data running on Intel and ARM with Windows and Linux container support. And it's very easily deployable through the IoT Hub or through the VS Code extension. This is going into preview today. The Databox itself now supports the REST API. This is interesting, not so much because you would use it as an end user, because you'll probably just copy data onto that SMB share and ship it off to us, but because we can have all of our partners that you and us use together, let's say a backup partners or an archive partner, they can just pretend like the Databox is a local extension of your blob storage account, continue to use the same API, write data in, and it acts as like a disconnected container, ships in, and appears on the other side. So that works out really well. Azure Data Lake Storage Gen 2, there's a talk here on this on Thursday. This is a very, very cool feature because we've added a hierarchical namespace on top of the flat object namespace of blob storage. This allows us to natively mount a blob storage account as a Hadoop file system with full support for things like renaming directories at any level, renaming blobs, blob-level ACLs, and things like that. And the beautiful thing about this is it's a multimodal API. You can continue to read and write data into your application using the familiar blob API, and your analytics clusters can mount that same data as an HDFS file system and read and write at the same time. So if you're interested in more on this, please do go to that talk. So in summary, we've done a lot of work over the last couple of years, and that we're announcing here and over the last few months. One, certainly improving durability with the ZRS GA earlier this year and the failover options that Klaus talked about. The security and compliance features, particularly AAD authentication, which has been a long-standing ask for many of you, and the immutable blob storage. You saw Klaus show off the fantastic performance improvements that we have now in blob storage for those sort of scale-up scenarios. And the premium blob storage address those low latency workloads. Archive continues to expand, and now the data lifecycle management allows you to deal with data lifecycles automatically. And you look finally at that serverless app architectures and app development. If you have any questions about any of this, please do feel free to send us email, Azure Storage Feedback. It's us product managers who are always looking at those and answering them right away. These are the related sessions that I put up earlier. If you're interested, we'd love to see you later this week. One thing that I'd throw out here is we have a small reception for our customers right outside the expo area in rooms 208A and 208B on Wednesday from 3:30 to 6. We have beer and food and some things, so please come on by, say hi to us, or network amongst yourselves. We do have these tickets here, so if you're interested, just come on by after the talk and pick one up from us. So that way we don't exceed fire safety violations and all of those things that conference venues tend to worry about. So please do pick up a ticket. We have some stickers as well. So hopefully this talk was useful, gave you a good overview of the new blob storage features. We'll be here after, as long as you need us to answer any questions, so please come by and talk to any of us. Thank you.